Okay, and a good morning to everyone. And Ernie, I'm getting feedback. And the microphone is on, and I'm getting feedback. So I'm not sure what's causing it. Let's see how that goes, okay? What happens then, out of curiosity? Oh, okay, so you need to bring it back down. Okay, thank you. Now, during the weekend, you were supposed to work on what unit? The counting unit. I asked you to work all the way up through the unit test. How did it go? I can't tell from your expression. Will you open up that page? What page is that? 20. Page 20. Okay. On page 20, you had some problems that you were supposed to do. And just looking at a few things that I can see from here, it looks like a number of you were working on that. That looks good. Okay, I'm trying to see far enough back if I can. It's page 20. Okay, that's okay, I'll get it later. Page 20. Let me put that up here on the screen. And here was the counting test that we're talking about, and it started with rearranging the stars in groups of 3. Okay, and the idea was to get groups of 3, then 3 groups of 3 became a group of 9, and hopefully you were successful with that. Let's come off there for a moment. In the second problem, you were to start with 1 and go up to 100. That's in base 3. Then off there, in the third problem, you were to use expanded notation and powers of 3. By powers of 3, I mean 3 to the 0, 3 to the first, 3 to the second. And you were using expanded notation. And what you were, of course, supposed to do is take this number, 210,201, and use expanded notation. Then, in this problem, you were to show these two numbers were the same value. That is, 2 different ways of representing the same number using expanded notation. And then finally, I ask you to write 144, the typical gross 12 dozen, as a base 7 number. So that's what you should have accomplished. This unit should be done at this point. You should have all the problems finished, the unit test finished, and by the end of this week you should be ready for an exam on this unit. Okay, so that means end of the week, thinking in terms of a test on the counting unit. That would be something like 8 to 10 problems, and we would have a bit of a review and then take the test. So that's what I'm looking at towards Thursday. So that may be subject to change, but at this point what I would then do is collect the book for each of you, and I would go over that unit expecting to see all the work done on all the problems and the unit test, and then I would okay it. Just like I've been okaying your 1 through 6 on the computational review, the white book. Okay? Now, I had a problem that we worked on. Remember this one? Pretty sick-looking multiplication table. But we did this multiplication table. We tried this, where we had a 0, 1, and 2. And we said 2 times 2. This is base 3 now, because we're only using 3 digits. So base 3. And so the argument was that if you had 2 times 2, it was a 1, 1. Do we still remember that? We okay there? Let's do another one like that just as a review. I'm going to change that a little bit. So let me get another piece of paper out here. I feel like I'm pulling something off the table, like the old trick where you take a tablecloth and you pull it out from underneath all the dishes, theoretically. Let's change it so we're in base 4 this time. Let's go base 5. You're right, I did a base 4. So let's go to base 5. I heard the comment. Okay. So here's what I've got going. If I can get, there we go. Now, I want 4 times 4. 4 times 4. Base 5. We're in base 5. Okay, I'm hearing a 100. I don't think I'll go with that. I'm in base 5. 4 times 4. How do we do it? Well, I'm hearing a 1-4. Do I hear any other choices? Base 5. 4 times 4. Close, but not close enough. Not 2-0. What is 4 times 4 usually? 16, correct? 16? 4 times 4 is 16.
It's Monday.
Yes, it's Monday. How many nickels and pennies for 16 cents? 3 nickels and 1 penny, correct? 4 times 4 would be 16. Convert it to pennies and nickels. 3 nickels, 1 penny. So if I write that number down here, I would have 3-1. Okay, let's try 4 times 3. So I'm taking the 4 across here and the 3 down here. So I have 4 times 3, which is normally 12. That would be how many nickels? 2 nickels and 2 pennies, so the 2-2 is a good answer. Oh, 2-2, and I wrote 2-3. I saw that 3. So 2-2. Now let's take this one, coming across here, down here, 3 times 3. 1-4. I heard this answer. Do you agree? 2 of you do. That's not very good. How am I doing that? 3 times 3 is 9. 1 nickel, 4 pennies. Get the idea? Okay. What is 2 times 2?
2.
We get a 4. That doesn't change, right? It's still 4 because the answer is smaller than the base. Okay, that's enough damage there. If you want to challenge yourself, just try doing some multiplication tables in different bases, and it'll really give you a way of bouncing back and forth from one base to another base. Basically, bad pun, from base 10 to a base 5 or a base 4 or a base 2, a base 3, and so on. Any questions? You know what you need to do by the end of the week? Spend time in the unit, and I really encourage you to get together as small groups. We, on Friday, in the other class, have been getting together Friday mornings, and that has just worked fantastically well. Getting a group together here on campus on Friday mornings and spending an hour to answering questions, reviewing problems, and it really seems to be making a difference. You can do the same thing, get a small group together in the student center, the fireside room where they have the big TV. Most of the time it's off right now. Sit down at a table and try to work some problems together. Fantastic way of making it work. Okay, we are now back to the computational review, and we're into the unit on subtraction. So what I'm going to do is put a problem under the document cam for you. This is lesson 10. So as we go to lesson 10, here's the problem I'm going to write on the board. I have it on the board. And I'll just show you what we have here. See if we can get a little bit of light on there. Let's try this now, Ernie. There's the problem. We're going to go to the board on this. And as we go to the board, I'm going to take the light off there. Let's see what we have. This is page 97. This is the problem. And as we come back to the document cam for just a moment, what I did for you, see the multiples of 3 and multiples of 8 you see in the bottom of the page 97? I'll let you look for a moment on page 97. And we're looking at the bottom of the page. I have multiples of 3 and multiples of 8. Now, coming to the board, That just means I'm counting by 3s and 8s. And this is the problem up here. So I'm counting by 3s. That means I take 3 times 1, 3 times 2, and so on. And so I get this list of multiples. Notice it starts with 3. Now, I give homework assignments this way in the algebra classes. And I expect them to start with 3, go to 6, go to 9, go to 12, and so on. And I carry that list. I do the same thing with 8s. 8, 16, and notice right here in these two lists I have what? The same number. It's the first number that matches up. So we call it a lowest common multiple. And the abbreviation is LCM. Because these were denominators, we call it an LCD. Now that is not lowest common denominator. The word that we use is least, L-E-A-S-T. So the L stands for least, meaning the smallest. Now what I want to do is change each of these denominators to a new denominator, and that new denominator is the 24. Now I make a comment here that we talked about earlier. 3 and 8 are relatively prime. Do you remember what that meant? It means I can multiply together to get the LCD, but what does it mean to say they're relatively prime? The only number you can divide into them evenly is 1. Again, the 3 and 8 can only be divided by a 1, meaning both of them divided by the number. So they are relatively prime, and so without doing this, I could have immediately said it was what? 24. Now I need to know what to multiply times the 2 up here. Well, 3 into 24 went 8, correct? And basic principle of fractions says that whatever I do in the denominator must be done to the numerator. So this becomes 16. Now note, I could have just counted how far down the list I was. 1, 2, 3, 4, 5, 6, 7, 8, and avoid the division. So there's a shortcut. Again, if I'm listing the multiples, just find how far down the list you are, and I'm at the 8th number. That's why I multiplied by 8. So changing the 8 to 24, I'm in the 3rd number. That's why the 3, without dividing. Otherwise, I'm trying to avoid division, and so I get what? 15. And now the subtraction, not the addition this time. Note down here, there's a subtraction sign. So I'm going to go to that intermediate step we talked about, just to remind you of what we're doing. And of course, that is 1 over 24, and I'm done. And that's pretty much the process. As long as the denominators are what? Nice numbers. Otherwise, the denominators were the same here, but they were easily changed. That's not always the case. This just happens to be an example where the numbers are nice. Now, I'm going to slide over to this problem, and I've illustrated something here that is the most common mistake. I've tried to not illustrate it, show you what should be done. But let me illustrate what often is done as a mistake. We're taking 5 and 2/3. So my original problem was what I have here. Let's slide over just a little bit more, Ernie. Okay, this was my original problem right here. Now I have both of those together. Now what I want you to realize that as I look at this one, we're supposed to borrow. Let me show you the mistake that is made. So this is yes. This will be no. So yes and no. Here's what sometimes gets done. And that is a bad first step. Because you didn't borrow 10 to make that a 12. You borrowed a 1. So your 1 2/3 actually becomes what? 5 over 3 rather than what? 12 over 3. So this is a huge, huge mistake because of the way you usually borrow when you subtract numbers. That's another argument for not borrowing with numbers, whole numbers, and using the Austrian method. This is wrong. Okay, so be careful. Don't do this. So let me get rid of the no there. And get this back to where it originally was, because we're going to do it in a different way shortly. So the key is we do this as a first step. Now, I have a 7/8 still here. So let me get rid of the yes. My denominator is still what? We're still dealing with 3s and 8s, aren't we? So it's still just 24 without doing any hard work there. So I'm going to make this over 24, this over 24. Okay. Now, just a comment so you understand why I borrowed, and it may not be obvious to you because I did a step that was probably not adequately explained. Let me go back and look at this just as 2/3 minus 7/8. I'm arguing that this is bigger than this. Now, if you've ever looked at a measuring cup, 2/3 and 7/8, this would be the bigger number. And I can't subtract without borrowing. But let's see what happens. This is over 24, so this would be an 8 here and an 8 here. We know that already gave us a 16. Here I'd have to multiply by what? A 3, and that would give us a 21, and I can't subtract. 16 minus 21, I have to think in terms of borrowing. Now, if we later, in a pre-algebra, think about signed numbers, I could argue this has an answer. But in basic review of arithmetic, no, this is not something we can do. So that's why I borrowed here and have this now at 5 over 3 instead of 2 over 3. Now what do we get at this point when I multiply by 8?
40.
Okay, Lewis has it. A 40. And then the 3 that I had here gives me the 21. And now my intermediate step is 40 minus the 21 over the 24, and what do I get? Can you do that one just without writing it down? 40 minus 21? Okay, the shortcut would be to say this. What's 40 minus 20? That'd be 20, right? That's an easy problem. And this is just one less than that, so you're at 19 over the 24. Am I done? Okay, can you give me just a little more space here, Ernie? Am I done? Critique. You're happy with that answer. 19 over 24. Yeah. You should be upset with me. What didn't I do? Can it be reduced? 19's prime. The only thing that will divide 24, 3, 8, 2, 6, 4, but not a 19. It is reduced. You still should be upset with me. I can't make 19 over 24 a mixed number because 19's smaller than 24, but you still should be upset with me. What's a mixed number? Ah, yes. I had 4 here and a 2 here. Did I ever subtract that 2 from the 4? I didn't. So I should have down here what? A 2 here and a 2 here. So my answer is 2 and 19/24. Okay? It's easy to make that mistake because you get so caught up in borrowing and you get caught up in the new denominators. Easy mistake to make. How can we avoid it? Do it immediately. Otherwise, when you start up here and you borrowed, immediately bring the 2 down. That's the best way of getting around it. What's another method I could use to avoid the error? Don't borrow. How can I do the problem if I don't borrow? The Austrian method. Not bad, not bad, but it's a little bit harder to do with fractions.
Can you multiply the denominator times the
Yes, I can.
and then add the
Yes, I can.
denominator?
What's being suggested? Can I multiply the 3 times the 5 and add the 2? We make it into a, or an, I'm sorry.
Yep.
Make the mixed number into
Fraction.
what kind of fraction? Improper fraction. Exactly. Make this into 17 over 3 and this into what? Do you agree with what was said or did you hear it? I'm hearing a 23. Do you buy it? 8 times 2 is 16. Add 7. I mean, they aren't going to support you. Just leave you out in the limb. Hang you out there to dry. 23 over 8. Okay. Yeah, if nobody agrees with you, you start saying, God, what did I just do wrong? They aren't very nice to you at all this morning. But you understand, it's a Monday morning. No coffee yet, probably. Okay, makes a difference. Of course, if you'd had breakfast, you might be sleeping at this point because all that energy going into digestion. No win here. Now what are you going to do?
Make the common denominator.
Still, it's the common denominator. Now here's the downside. With 24 as your denominator, these fractions are going to what? Have some big numbers compared to what we had over here in this solution. The 40 and the 21 were big, but not that bad. Let's see what happens here. Okay, so I have my equal sign. It's at 24. Here's at 24. Okay, I'll do this one first. Remember, we multiplied by 3. Agreed?
Yeah.
So we have a 3 here. Basic principle, the 3 in the numerator. And so 3 times 23?
69. 69.
I'm only hearing a couple of people, and the rest of you aren't nodding or anything. If you agree, you nod like this. Okay, we have a clicking system that we can invest in here at the college, and you click your responses if you agree. A head nod does much more for me, and it doesn't cost $60 a unit. So you just nod for me. Do you agree with the 6, 9? I hope you do. Okay, what do I multiply?
8.
The 8 here.
136.
Okay, the 8 here. So the 8 times 7 is 56. Carry that 5. And the 5 and 8 is 13. So we have 136. Now I said the numbers get larger. Does that make a problem for us? In a way. It was a lot easier to subtract 21 from 40 than it is to subtract 69 from 136. But let's write it down. Intermediate step. 136 minus 69 over the 24. Now what does that give us? Be careful. Be careful. I've heard 2 different numbers. I haven't heard.
She's right.
Okay, I hear several of you with a 6, 7. Okay, so a 67
My bad.
over 24. Now, are you going to be inclined to leave that as 67 over 24?
No.
I see this going from a couple of you and heard a no. Give me a defense. Because I've told you that that's okay.
Improper fraction.
Well, improper fractions are okay. Why would you? Very good. The answer, the problem started out with mixed numbers, so I'm extending a courtesy by coming back and saying that that's the same as what? 2 and 19/24. Just as a courtesy, because somebody started the problem with the mixed number at the beginning. Any question there? Over here on this, the question, why didn't I borrow from here? Okay, because I changed to an improper fraction, this numerator here is larger and I don't have to borrow. That was to avoid the trap. Okay?
So we can do it that way?
Yes, you can always do improper fractions. But what's the downside? You know, the idea, no free lunch. You get rid of the trap, but then you get bigger numbers, and it's a lot easier to do what? Make a simple mistake with a larger number that you wouldn't make with smaller numbers. Okay, so this is certainly has some advantages. Now, I'm going to take a moment, because this is, at least for the moment, a problem that isn't bad. Now, Ernie, what camera are you on? You want to go to camera 1 for a moment? Try to get about the same shot for me in camera 1, because I want you to free up camera 2 so you can go to the sideboard with that problem I have over there, and then we're going to do one very similar to it. But I want to show you why we might not want to do what I just did here. So when you get camera 1 here, okay, and what I'm going to do in a moment is I'm going to go over to the sideboard. I'm just going to leave this up here, and we're going to refer back to this a couple times, Ernie. So when I walk off camera and we go to camera 2, then what I would like in camera 2 is just pretty much the problem in the first part of that. I'm not too worried about getting in all the division and everything. So pretty much just the problem, and in fact we're going to use primes to get the LCD. Okay, so it's a whole different ball game, but I'll walk off camera here. We'll leave this one up here for you to look at for a moment. And the question, am I always willing to deal with the problem of potentially borrowing by going to improper fractions? I hope you realize that I'm going to have to borrow here. 11 over 48 is less than a half. Agreed? That should be pretty straightforward. But 25 over 36 is more than a half. So this fraction's bigger. Well, let's just set this up as improper fractions for a moment. Anybody in your head? Give me the new improper fraction for 5 and 11 48ths. So that means you have to take 5 times 48, which is what? Okay, be careful. Okay, it was 240. 5 times 48 is 240, plus 11 is your 251, over 48. Things are getting big, right? Okay, what about the next fraction? This one as an improper fractions. 2 times 36 is 72 plus 25, 97 over 36. Things are getting big, right? Might not be the best way of going this, and I'll just tell you up front, the LCD is 144. Now, are these relatively prime? Going back to that question. 48 and 36. Are they relatively prime? No. The answer is no. Why? What can they be divisible by? 2. What else? 3, 4. What else? 8 won't go into 36, but what will? 6, 12. They are not relatively prime. Now, it turns out the LCD is what? 144. So what could I do with the 48? How many times does it go into 144? It goes 3 times. 3 times this is a 3, a 15, and a 7. Do we agree? 753? You aren't agreeing with me very fast. 1 agreement, 2 agreement, 3 agreement, 4. 5 potatoes, 6 potatoes, 7 potatoes more? Okay, same idea. Some of you go, what? Okay, now, what times 36 will give you 144? No, I want to know what times 36? A 4, correct? 4 times 36. So what's 4 times 97? I'm hearing a 384. Do we agree with that? We do? What's 4 times 7?
Oh, 7. I did 96.
Okay, let's try again. What's 4 times 7? 28. So I know it has to end in an 8. 388. If you're sitting there and thinking, I'm not going to do that, you're right. Most people don't want to do that. So what can we do instead? Borrow. So this is, I guess the question, do you always want to go to improper fractions? No. Nice fractions. Smaller fractions, not too shabby. But something with a 48 and a 36, nah. Now let's come back up just a little bit, Ernie. Just zoom out just enough to pick up this 48x and 36x. Thank you. The technique we'd have to use so far is counting by 48s and 36 to get 144. I'm going to jump ahead to the next lesson, which is lesson 11. This is about the second time I've presented this, but by the time we do it 2 or 3 times, I'm hoping you own it and you feel good about it. So I'm going to use primes to get this LCD. So that means I'm going to write 48 and 36 as a product of primes. Now, Ernie, I just want you to stay with where you are, and I want to just rotate this way and see what we've done here. Because this is old hat at this point. It's supposed to be old hat. I took the 48 and divided by the first prime. That gave me 24. It was even, so I could divide by 2 again. I got 12. It's even. I can divide by 2 again. I get 6. It's even. I sound like I'm repeating myself. I can divide by 2 again. I get 3. I cannot divide by 2. I divide by the next prime 3, and I get what? How many 2s? 1, 2, 3, 4. So it's 2 to the 4th, 3 to the 1st. Now the people watching this at home this afternoon have an advantage over you because you can see some of the rest of the board, and I'm very carefully determining what somebody watching this on a television broadcast is able to see. Because I next go to what? The 36. And 2, again, will go into 36, giving me 18. It's even. So 2 will go again, giving me 9. Not even. So I go to 3. That gives me another 3. One more time. So how do I write 36? 2 to the second, 3 to the second. Now, we've been there enough times that you nearly have the T-shirt that says, I've been there and done that. So what? Now, Ernie, we're going to pan a little bit. So if you'll pan with me, and we aren't doing gold. Okay, so we aren't at Columbia. We'll just slide over. And I need to go up just, no, too far. There we are. And there we go. So there's my 48 and my 36. Now the question, how do I get this LCD out of these two factorings, 48 and the 36? Well, the only numbers I used over here, so come back just a nudge, a little bit more of a nudge. There. The only numbers I divided by were what? 2s and 3s. Those are the only primes I had to use. So I write down just the primes I used, which were 2s and 3s. I'm going to multiply them. Now the 4 comes out of this question. I had 2 to the 4th, 2 to the 2nd, so what was the largest exponent? The 4. The exponent is 4 and 2. The largest exponent is this 4. Hence 2 to the 4th. Okay, I had 3 to the first and 3 to the second, which is the larger exponent, the 2, so this is my LCD. 2 to the fourth, 3 to the second. Now the 3 to the second is not 6, it's 9. It's 3 times 3. And 2 to the fourth says I have 4 2's I'm multiplying together. So the first 2 of them give me 4, the next one an 8, the last one a 16. And 9 times 16 is the 144 we used. Okay? Now, of course, the question, do I know when I start out that I'm going to have to borrow? And the answer is pretty clear. Again, the same argument. 11 over 48, less than a half. 25 over 36, more than a half. That means I'm in trouble. So I come here, and I have the 144. Okay? And here's the question. I had 33 over 144, and I have 100 over 144. Now the question you may be asking, where did that 1 come from that I had right there? If I'm going to borrow, I have to borrow from what? The 5. That leaves a 4. And this 1 doesn't come up here with 133 like you do in a basic subtraction problem. It's that same trap. It is a 1 and 33 1/44ths. Now the shortcut of going from here to here, and we can slide a little bit more, Ernie. Give me a little more space because I'm going to back up a little bit. Okay, there we go. Now the shortcut to go from here to here, since it's always a 1 and something, just add these two numbers together. And you get 177. Okay, so I have these two here. What do I have to be careful about that I don't get trapped in? What was our trap last time? We talked about it. The mixed part. Otherwise, we had the 4 here and the 2. You've got to remember to bring down that 2 immediately, because after all this mess, and you get down to this 77, because I subtract 100 from 77, there's a tendency to do what? Write down 77 over 144 and say, okay, I'm done, I'm out of here. So be careful that you do this subtraction first. Now question, is 77 over 144 reduced? My question, is 77 over 144 reduced? Give me an argument. Okay, it is, yes. Give me an argument. Be careful. If it can be reduced, then it was not done. What are the only things that will divide 77? Okay, 1, 7, 11, and 77. So it's 7 times 11, correct? And 7 and 11 are prime. Is a 7 or 11 part of 144? You said nope. Defend it. Okay, it's even. That wouldn't be a bad argument if I could divide by 7, but 28's even, and I can divide it by 7. The argument I was hoping you'd go to is up here. Your 144 involved what primes? 2's and 3's, that's it. No 7's, no 11's, so this was reduced. Okay? Now let's come back to right here. I'd like to look at this in a little different way. How do I know that I need to multiply 3 times 48 to get 144? Now you said I'll divide and that works. I'd like to do a different process here called Sesame Street. One of these things is not like the other. Very good. Okay. One of these things is not like the other. Okay, let's look up here. The 36 is what I had, and this is what I want. Agreed? How are they different? Well, here I have 2 2's, here I have 4 2's. That's the difference, correct? The 3 to the second is the same. The thing that's different is I have 2 more 2's here. So if I multiply this by 4, I have this. That's where the 4 came from here. Now, let's do the same thing with the other one. Here's the 48 I had. Here is what I want. How do they differ? Sesame Street criterion. Okay, this has 3 to the first. This has 3 to the second. So I'm missing a what? 1, 3. There it is. That's the comparison. Now, of all this problem, this mess, that last step is what's going to be critical in an algebra class when you do the Sesame Street method. That will be critical in an algebra class. For right now, you can do long division or short division, where you divide 36 into 144 and get the 4. It'll work, but it doesn't build. It doesn't open doors. Okay? Any question in that process? Okay, let's do another one, just to have fun. Okay, I started out with 5 and 11/48. I'll try to make it so it's not too much worse, and I'll leave this one down below as 2 and 25, but here's what I'll change it to. 56. I still may have to do what? Borrow, because this is about a half here, and this is a whole lot less than a half here, so I think I'm still into borrowing. Now, I could do this with multiples of 48, so I could still do 48x and 56x, but what am I going to do instead? I'm going to do primes. Are we ready? The 48 doesn't change. So the 48 we already know from our last problem is what? It's 2 to the 4th and 3 to the 1st. It's that pesky 56 that is going to cause me some trouble. So let's write the 56 here, my list of primes, 2, 3, 5, 7, 11, 13, 17, 19, just carrying that list around. And then I'm going to do what? What do I always start with? When I do the stairs, start with the lowest prime, which is a 2. And since 56 is even, 2 will go into it. What's 2 into 56? 28. Do we agree? Can I do 2 again? Okay, what is it this time? 14. Can I do 2 again? Yes, so I get a 7. Can I do 2 again? No. Can I do 3? No. Can I do 5? No. Can I do 7? You bet. So what is 56? 2 to the 1, 2, 3, 2 to the 3rd, 7 to the 1st. Okay, LCD time. Make it sound like I'm having fun doing this. LCD time. What do we get? LCD has to have what primes first? 2's, 3's, and 7's, because I divided by what? 2's, and then 3's and 7's. So what's my highest exponent in the 2? I have a 2 to the 4th, 2 to the 3rd. Highest is a 4. A 3 to the 1st, a 7 to the 1st. There it is. 2 to the 4th, we said, is 16. 3 times 7. 3 times 7, folks. It's Monday morning. You just went to sleep. 21. 16 times 21. 42? I've heard 22, 32, 42. This is going to be a 32. Do we agree? So I have a 3, 3, 6. A little bit larger than what? 144. Okay, let's see what we've got here. Let's see what we can do. This is getting messy. But we're having fun. That's the important part. I'm having fun. Let's see, I have 5 and 11/48. Agreed? And I'm going to change that to what? Something over 336. Okay, you tell me what I need to multiply by. Make the comparison. I had this is what I had. Okay, a little bit tighter, Ernie, because it's hard to see than I want up there. A little bit tighter, a little bit tighter, a little bit tighter. Keep going. Okay. I have 2 to the 4th, 3 to the 1st. Here's what I want. So what am I missing? Sesame Street time. The 7, right? 7 to the 1st. So that means I need 77 here. Because I multiplied 7 times 48 to get this. So 7 times 11 is 77. Then I'm subtracting off what? A 2 and 25/56. So all I'm doing is changing this denominator, that's 56, into something over 336. Okay? So this is a case where I'm using the language. I have 25 over 56, and I want you to write it as a new fraction with the denominator 336. Let's make a comparison. Here's what I had. Here's what I wanted. Sesame Street time. How are these different? The 3 and what else? Okay, I have 3 2's. Here's 4 2's. I'm missing a 2 and a 3. 2 times 3 is 6. So what's 6 times 25? 150. Let's slide over just a little bit more, Ernie. So I have some space to work with. Okay? About just to the edge here. Now, I'm in trouble, right? Because 150 is what? Larger than 77. So I'm going to borrow from here. What am I going to do with that 1? Put it in front of here. Okay. We're getting there. What am I going to do right now before I forget? Bring down this 2. Don't forget it. Okay, now, what is 77 plus 336? 4 something with a yawn. 77 plus 336. I'm waiting. 413. Are we agreeing?
Yeah.
One agreement, that's it. A couple head bobs going like this. We're getting a little bit more agreement. So I have 413 over 336. I have 150 over 336. Okay, I'm waiting. We're nearly done.
It's 486 over 330.
I'm subtracting.
Oh,
That was a great answer for addition.
yeah.
I'm subtracting. Phone up, please. Thank you. What is it? 263? Do we agree? I'm waiting for an agreement here.
186.
Okay, I'm taking 4, 1, and 3, and I'm subtracting 150, correct? Okay, so that's a 3. This is a 6, and this is a 2, because I had to either carry or borrow. So 263 over 336. Now the big question, is that reduced?
Yeah. No.
What are the only numbers I have to worry about going into 263? A 2, a 3, and a 7. Can it be divided by 2? No. Can it be divided by 3?
Yes.
2 and 6 is 8, plus 3 is 11. 3 won't go into 11, so no on the 3. Will 7 go into it?
No.
7 into 26 would go 3 times with a 5 left over, and 7 won't go into 53. I'm done. That is reduced. Well, that's the process that I wanted to review today that's in tomorrow's lesson. Yeah, I heard the comment, it's lovely, dropping with sarcasm. Okay, dripping with sarcasm. Okay, Ernie, we started with the cars, and you might think, before we do that, just a reminder, review test 9 is going to be due 10. Review test 10, due tomorrow. So just with that, we'll go to the cars. You might think that's cut number 14. Oh, you're going to do, that's part of it? Okay, good times roll with the cars. We'll go with that.